So in module 3, we'll see the next topic, that is sorting large files from disk. So here mainly we'll be seeing about merge sort, and as we have seen in the previous section about sorting from memory, we have seen about key sort and its drawbacks. It was like it was very expensive to do sorting from the memory because maintaining an index file and then trying to sort the data file was very much expensive. And we had a second drawback, like if my index is very large, it was difficult to do use key sort algorithm. For this, we had gone for the next the solution for this problem was introducing merge sort. Okay, and here what is the main how is it done means we are trying to break um, we are trying to break our files into sub-files known as runs. And then what we do means what is this runs done means we are going to retrieve each and every part of our main file as runs, and we'll sort each and every runs, and afterwards we'll put it as input to our merge sort. So now the merge sort will sort every run and output it to my disk. Okay, so this is what the merge sort works. So for looking into the advantage of merge sort, here we are having main two steps as I have already explained. The first one is reading the input, that is for a run creation step. That here the reading is sequential, and then the next one is we have to after reading we'll go for creating runs. That is, in the runs every data which is read has been sorted and saved as runs. Okay, so it is again written into the disk. Now we are going for the second stage where we are going to do the merging. In the merging case, now again what we have to do means we have to read the runs from the disk and give it as input for the merging. Once we do the merging, then what we have means we have the sorted files which is ready to be written to the disk. So after merging, we'll write the sorted disk sequentially into my disk. Okay, so we can tell, or the only here in this throughout the sequence, the only place where we don't have sequential access is whenever we are going to switch from one run to another run. Here the technique which is used for accessing is we are using random access. So here we can end up with long seeking time, okay, because it is not sequential. Here we can tell that we can try to introduce overlapping of input output similar to our heap sort, so that we can improve the seek time. Okay, this is also being tried so that to improve the performance of our algorithm. So we can tell here we have tried to improve the performance by maximum concentrating on making our access sequential. So tapes can be used. So here this is how it looks like. Consider that I'm having 800,000 unsorted records. Here this has been it has been divided into 80 runs. In the sense, one run is having 100 bytes. Okay, so similarly for 80 runs it will be retrieving that much data, 100 bytes, and for every 100 for each run it requires 80 seek for reading the whole data into one run. Okay, and then once each and every runs are available, each and every runs will be sorting the data and saving it inside the disk. So here the disk is being written with the 80 runs. Now what do means we do merge sort by reading again from the disk the sorted subfiles or the runs are being read from here, and it is given for merging. Now when we do the merging, the sorted files or the sorted runs are being written into my disk and we get the 800,000 records in a sorted order. So this is how my algorithm works. So we'll see it step by step. We can tell now the procedure is divided into two phases, that is sort phase, and the second phase is merge phase. Okay, so since we have seen that we have to mainly try to improve our performance. We try to improve our performance by telling that our seeks are always done by using sequential access, and the only thing which is addition is for every seek we have an rotational delay similarly, and for that is for every axis. Here now in sort phase we have many two steps, that is reading the data from the disk into the memory, and then we do sorting, and after doing sorting we save it into runs. Okay, so this is the first step. Second step is after the run is written, we have to write the runs into my disk. Then comes to the third step, that is in the merge phase. In the merge phase, we have two steps, that is reading the input or the reading the runs from the disk into the memory. And this runs are given to the merging as input. Once it is given for the merging phase for input, now the next step is writing. The merged data need to be written to the disk. So that is the fourth step, that is writing the data into the disk. So these are the main four steps. We'll see each by each so that we'll understand the algorithm. So the first step is, as I have already explained, it is reading the data from